Imagine this. The screen fades to black. A deep silence expands. And then a single sentence flashes through your mind, not as a thought you formed, but as something that was waiting for you, hidden beneath years of certainty. What if the firmament is real? Not real as in poetic or symbolic, not real as in atmospheric optics or scattered light, not real as in a metaphor our ancestors invented. Real as a structure, as a boundary, as something that exists, whether or not we've ever dared to see it. This is where our journey begins, not with answers, not with explanations, but with a question so disruptive that even considering it feels like stepping off the edge of the known world. Because if the firmament, this ancient idea repeated across dozens of civilizations, holds even a fragment of truth, then our entire understanding of reality bends. Not breaks, but bends towards something far larger, deeper, stranger. In this first chapter, I want to pull you into that space of tension, the space between what we believe and what might be hiding behind what we believe. The firmament appears in countless mythologies. A dome, a vault, a solid sky. A boundary between realms, a structure holding the stars. We laugh at those ideas today. We call them primitive. We call them allegories. But here's the unsettling possibility. What if those ancient cultures weren't describing imagination, but observation? Not of a physical dome, not of a literal barrier, but of a phenomenon they couldn't explain. A phenomenon we might still be misunderstanding. In this opening chapter, we won't reveal anything. We won't define the firmament. We won't expose some dramatic secret. Instead, we create pressure. We build the question. We establish the suspicion, a suspicion born from real, modern anomalies. Unexplained reflections at extreme altitudes. Density values that behave too sharply to be random. High atmosphere, hard horizons reported by early pilots. Signals bouncing back from regions where nothing should reflect them. Optical flickers seen by researchers long before satellites existed. Separately, they're nothing. Together, they whisper. They whisper that the sky may not be empty, that the transition between Earth and space might not be as simple as we think. Close your eyes for a moment. Visualize Earth from space. Blue, glowing, suspended in darkness. We take that image as absolute truth. But we often forget. Every image is processed, filtered, corrected, interpreted. We don't see space directly. We see space through instruments. And if something existed in the transition zone, something subtle, something patterned, something structural, would we even notice? Ancient texts describe a firm sky. Medieval scholars argued about celestial spheres. Early Renaissance astronomers still debated whether the heavens had density. Then suddenly, that idea evaporated. It became childish, ridiculous, and perhaps it was. But perhaps the problem wasn't the idea. Perhaps the problem was the interpretation. Maybe they saw something real, but explained it incorrectly. And maybe we're doing the same. This podcast will peel away those layers, not to argue for fantasies, not to indulge conspiracies, but to explore the limits of our models. The places where predictions break, where data shifts, where explanations become convenient. Because there is a kind of error more dangerous than ignorance. The error that appears too tidy. The error we accept because it keeps our worldview stable. The error that becomes invisible through repetition. In this opening chapter, I want you to feel one thing. Something is about to reveal itself, but not yet. That's the nature of a true mystery. It doesn't shout, it resonates. So let this question linger. If the firmament were real, not as a dome, not as a wall, but as a phenomenon, what would that mean? Not for science, not for cosmology, but for our sense of reality. Because the firmament, if it exists, wouldn't have to be artificial. It wouldn't have to be mystical. It wouldn't have to violate physics. It might simply be physics we haven't noticed. Physics we haven't understood. Physics we've chosen to ignore. Ancient minds saw a structure above them. Modern minds see an atmosphere fading into space. But maybe both perspectives describe the same thing. Two interpretations of one phenomenon we've never fully recognized. This chapter doesn't answer anything. It only opens the door, and once open, it can't be closed again. Imagine standing on a windswept plateau just before dawn. The horizon is a knife edge of pale blue, the air thin and sharp. Above you, the sky is still dark, still sleeping, still waiting. You look up, and for a split second you feel something. Not fear, not wonder. Something stranger, the sense that the sky is hiding a secret in plain sight. That feeling, quiet, subtle, almost imaginary, is exactly where this chapter begins. Because here we don't deal with revelations. We deal with cracks. Not cracks in the sky, cracks in our certainty. In the second chapter, our goal is simple: to transform the what if from a poetic question into a scientific discomfort. A problem with data, a problem with models, a problem that no one wants to look at directly. We begin with the earliest measurements of the upper atmosphere, late 19th century. Stratospheric balloons. Primitive instruments, yes, but instruments that returned baffling readings. Density drops that were too steep. Temperature gradients that were too abrupt. Transitions too sharp to fit the equations. Researchers chalked it up to error. Of course they did. What else could they do? But the errors kept repeating. Fast forward to the mid-20th century, high-altitude military flights. Pilots reported hard visual horizons, strange optical phenomena where the boundary of the sky seemed unnaturally defined, as if it were a surface rather than a gradient. Again, dismissed. Fatigue, reflection, imagination. Except these reports were nearly identical. Different pilots, different years, different aircraft, but the same words. The sky felt rigid. And then there are the radar anomalies. This is where things get interesting. Certain radar systems, military, civilian, scientific, occasionally detect reflections from altitudes where nothing should reflect. No clouds, no meteors, no debris, no aircraft, no ionized layers dense enough to return a signal. A ghost return, a phantom echo. Once, an error. Twice, a glitch. Hundreds of times, across different continents, different decades, different technologies. A pattern. But here's the catch. The pattern isn't consistent enough to form a conclusion. It's just consistent enough to raise suspicion. That's what this chapter is built on. The uneasy space where coincidence stops feeling like coincidence. There are countless examples. Atmospheric layers behaving like membranes instead of gradients. Sudden density shelves at altitudes where the air should be thin and smooth. Optical flickers that travel horizontally, too fast to be satellites, too structured to be lightning. Energy signatures that appear and vanish with geometric precision. Each one of these alone is harmless. Together, they form a question that modern science carefully steps around. Why does the upper atmosphere sometimes behave as if something is shaping it? Not a dome, not a wall, not an object, a behavior, a response. This chapter is about introducing that possibility, not as a theory, but as a puzzle with too many matching pieces to ignore. Let's dig deeper. Above a certain altitude, about 85 to 100 kilometers, strange physical behaviors begin to appear. The air becomes too thin to scatter light effectively, yet pilots have reported reflections as if hitting a translucent surface. Radio waves unexpectedly bend or bounce. Instruments record abrupt changes in drag on high-altitude vehicles. And here's the critical point. These anomalies aren't random. They cluster. Same altitudes, same conditions, same signatures. It's as if there's an invisible boundary that doesn't behave like matter, but behaves like something. The scientific explanations vary. Ionization pockets, measurement noise, unknown thermal gradients, localized plasma phenomena. All convenient, all plausible, all incomplete. Because if plasma pockets were the cause, why would optical reflections occur? If thermal gradients were to blame, why would radar signatures match them? If sensor noise were the reason, why would pilots describe the same phenomena decades before such sensors existed? Something ties it all together. We don't name it yet. We don't define it. But we feel its outline. And this chapter pushes us toward a crucial realization. The anomalies are not anomalies. They are symptoms. Symptoms of a system we haven't recognized because we've never expected it to exist. Imagine looking at waves on the surface of the ocean, not realizing there is an ocean. You see patterns, ripples, distortions, and you explain them one by one. But you never consider that the surface itself is part of a larger system. That's where we are with the sky. We're explaining the ripples. We're ignoring the ocean. This chapter leaves us with a single, growing tension. What if the sky isn't passive? What if it isn't empty? What if the upper boundary of the atmosphere is doing something? Not out of intention, out of physics. And if that's true, then everything we think we know is sitting on top of a hidden mechanism we've never acknowledged. A mechanism waiting to be understood. A mechanism we'll soon confront. But not yet. Not in this chapter. For now, the cracks are enough. Imagine standing on the peak of a mountain, far above the cities, the noise, the heat. Up here, the sky feels closer. Not metaphorically, but physically. Its darkness is sharper. Its clarity feels unnatural. And in a single breath, you sense something you were never taught to sense. That the sky isn't just above you. It's doing something. That subtle intuition is exactly where Chapter 3 begins. Because by now, we've seen enough anomalies to know something is off. But this chapter takes us deeper. From scattered observations to a framework. A suspicion that the sky may not just be a boundary, but a behavior. Let's begin with a question that sounds absurd until you look at the data. What if the upper atmosphere acts like a system? Not a structure, not a dome, a system. Something with patterns, rhythms, responses. Scientists often use this word, system, to describe complex phenomena that generate behavior not found in their individual parts. Think of wave patterns on shallow water, magnetic domains in metals, the boundary between two fluids, the edge of a storm front. None of these are objects, yet all behave as if they were. Membranes, interfaces, boundaries that aren't material but functional. Now look at the upper atmosphere. Around 90 to 100 kilometers above Earth, the physics changes. Light behaves strangely. Plasma forms structures. Waves propagate in ways that shouldn't happen. Reflections appear where nothing should reflect. Temperature curves bend where they should smooth out. It's the kind of behavior you would expect from an interface, not a gas. This is where we introduce the central idea of this chapter. The firmament, if it exists, isn't a surface. It's a transition. a transition between two different regimes of reality, the atmospheric and the cosmic. Transitions create structure. They always do. When two phases meet, liquid and gas, solid and liquid, magnetized and non-magnetized, something emerges in between. A boundary zone with properties neither phase has alone. That boundary behaves like a surface, even when nothing solid exists. Now imagine Earth's atmosphere meeting the medium of space. Plasma, radiation, particles, fields. The boundary between them would behave like, exactly, a membrane, a non-material one, a dynamic one, a patterned one. And suddenly, all those anomalies we've cataloged begin to make sense. Optical flickers, light interacting with a textured interface, radar ghosts, signals rebounding off a non-solid threshold, abrupt density layers, energy structuring the boundary, cyclic pulses, resonance patterns within the interface, satellite drag anomalies, vehicles passing through a changing transition zone. A scattered mess of strange data becomes a coherent hypothesis. But here's where things get emotional. Because if the sky is a system, then it is not passive. It reacts. Just like a drum skin vibrates when struck, a stretched membrane ripples when disturbed, a magnetic boundary shifts with external fields. Pilots have described sudden, hard horizons. Astronauts have reported flashes at altitudes too low for cosmic rays. Balloon sensors measured abrupt steps in density profiles. High-altitude aircraft observed shimmering lines that moved like waves. The modern interpretation? Measurement errors? The ancient interpretation? The firmament. Our interpretation? Not yet decided. Because in science, uncertainty is not failure. It is invitation. This chapter deepens that invitation by introducing one more crucial piece: patterns. When something repeats, even imperfectly, it suggests organization. Across decades, the same altitude bands produce the same anomalies. The same electromagnetic behaviors appear. The same optical features manifest. Something is there, not a thing, a behavior. And behaviors arise from systems. This chapter shifts the narrative from mystery to inevitability. If two regimes of the universe meet above us, air below, cosmic medium above, then an interface must exist. And if that interface exists, it must behave. And if it behaves, we can observe it. And if we observe it, we can finally ask the real question. If the sky behaves like a system, what is it stabilizing? We won't answer that yet. Not here. But in this chapter, for the first time, the firmament stops being myth and starts becoming mechanism. You feel its outline, its presence, its logic. The sky is not empty. The sky is not simple. The sky is active. And that changes everything. Imagine an abandoned observatory on a lonely hill. Dust covers the old machinery, the cables, the notebooks left open decades ago. Yet the room doesn't feel dead. It feels paused, as if someone had been observing something so strange, so out of place, that they simply stepped away, unable to reconcile what they saw. This is exactly the atmosphere of Chapter 4. Because this is the chapter where the anomalies stop being random and start becoming uncomfortable. Not because they reveal anything outright, but because they refuse to disappear. Scientists love clean data. They fear persistent noise, and the upper atmosphere is full of persistent noise. Let's begin with a simple, brutal fact. For more than 70 years, instruments have detected energy reflections at altitudes where nothing should reflect. Nothing dense, nothing structured, nothing material. But the reflections happen anyway. Sometimes radar, sometimes optical, sometimes electromagnetic, always in the same band of sky. And every time, the explanation is the same. Error, interference, instrumental anomaly. Convenient, predictable, reassuring, except they keep happening. Different countries, different decades, different sensor designs, same phenomenon. This is the turning point of Chapter 4. We stop being able to pretend that these irregularities are meaningless. Let's go deeper. During the Cold War, high-altitude reconnaissance aircraft often reported what they called false horizons. The pilot would climb, expecting the sky to gradually fade into darkness. But instead, at certain altitudes, a sharp boundary appeared, a thin, defined line, as if there were a surface. No one wanted to record these observations formally. Too bizarre, too incompatible with the equations. But the pilots talked. They described the same thing, over and over. A horizon that felt too exact. Now, add to that the data from atmospheric probes. Small rockets fired into the upper atmosphere in the 1950s and 1960s showed something remarkable. Sudden jumps in density and pressure. Small but impossible to explain with known physics. Thermal inversions, some said. Localized ionization, others insisted. But here's the problem. The thermal inversions happened at the same altitude every time. The ionization pockets appeared in symmetrical bands. The localized events were not local. They were global. Patterns. Scientific models hate unexplained patterns. Because a pattern is not noise, a pattern is a fingerprint. And this chapter explores that fingerprint. Imagine for a moment that the upper atmosphere is not a smooth gradient of thinning air. Imagine instead that it behaves like a semi-stable threshold, an interface where two environments collide, where energy organizes itself, where waves, particles, and fields behave differently because they must. That interface would not be solid. It would not block anything. But it would act like a mirror, a filter, a resonator, a boundary, exactly the behaviors we see. This is where the emotional tension rises. The realization that science hasn't been ignoring the firmament. It's been explaining it away, not maliciously, not conspiratorially, but defensively. Because no existing theory comfortably accommodates a dynamic interface above our heads. This chapter also introduces another important clue: satellite anomalies. Across decades, various satellites have reported tiny but systematic deviations in their orbits. Minute changes in drag or trajectory that shouldn't exist and can't be fully explained by space weather or atmospheric fluctuations. A one-time deviation is error. A repeating deviation is structure. And a structure at a consistent altitude is a boundary, not a solid one, an energetic one. This chapter leaves us with one clear realization. We are observing something real, but without a name for it. This something is not a dome, not a physical shell, not a literal solid sky. It is a region with properties that interact with light, energy, and matter. Properties that create patterns. Properties that feel like echoes of ancient descriptions, blurred through centuries of myth and rediscovered through decades of data. Chapter 4 ends by sharpening the central tension. We haven't discovered the firmament. We've rediscovered it, piece by piece, measurement by measurement, anomaly by anomaly. And the deeper we look, the more undeniable it becomes. Something above us is behaving like a boundary. The question now is, what is it a boundary between? That answer lies ahead, but not here, not yet. Imagine descending into an underground research chamber, quiet, cold, and humming with machines that measure the universe in numbers too small for human intuition. Scientists gather around a monitor. A new data set has arrived, and with it, something unsettling. A pulse. not a heartbeat, not a signal, not a pattern created by any human device. A natural pulse, coming from the upper edge of the atmosphere. This is where Chapter 5 begins, because this chapter is the descent, the moment where the mystery stops being philosophical and becomes empirical. Here, tensions rise, questions multiply, explanations crumble, and every new piece of data makes the sky feel less like emptiness and more like a system with its own behavior. Let's start with the phenomenon that ignited decades of quiet alarm: the atmospheric pulse cycle. Across global measurement stations, Japan, Norway, Chile, Canada, Australia, scientists detected the same anomaly: a rhythmic fluctuation in energetic density around 9,100 kilometer altitude. Too slow for electromagnetic waves, too fast for atmospheric tides, too structured for random turbulence. A pulse, repeating, coherent, global. And here's the part that no one could explain: it stayed consistent even when all known variables changed. Solar activity dropped. Pulse continued. Geomagnetic storms ended. Pulse continued. Seasonal cycles shifted. Pulse continued. It was as if the upper boundary of the atmosphere had its own clock. But a boundary can't have a clock. Only a system can. This is the turning point of the chapter. The realization that the atmosphere's edge might not be a passive region, but an active interface. And active interfaces always do one thing: they regulate. Let's explore that idea. At the boundary between two systems, water and air, heat and cold, pressure and vacuum, patterns appear. Ripples, shock fronts, gradients, oscillations. These patterns are not static. They're dynamic, emergent, and adaptive. Now imagine the boundary between Earth's magnetic field, solar wind, atmospheric plasma, cosmic radiation, and the thinning gases of the mesosphere. An incredibly complex, constantly shifting mix. A place where energies collide. A place where structures might emerge. A place where oscillations aren't just possible, they're inevitable. And suddenly the atmospheric pulse doesn't seem strange at all. It seems expected. But this chapter goes further. Because something else was discovered, something far more dramatic. The pulse responds. After volcanic eruptions, the pulse dampened. After geomagnetic storms, it intensified. After high-altitude nuclear tests in the mid-20th century, it shifted temporarily, and then restabilized. This was the moment scientists realized something extraordinary. The boundary behaves as if it adapts, not intelligently, not intentionally, but physically, the way a drumhead adapts to pressure or a magnet adapts to external fields. This leads us to the emotional core of Chapter 5. What we've always called the sky might be a membrane. Not a dome, not a wall. A membrane, dynamic, reactive, and structured. Think about what that means. A membrane can vibrate, carry waves, reflect signals, amplify disturbances, regulate interactions between two environments. Everything we observe at 90-100 kilometers matches these behaviors. This chapter also introduces the next level of tension: the subtle alignment between the atmospheric pulse and external cosmic cycles. The pulse sometimes syncs with solar oscillations, at other times with Earth's magnetic drift. Rarely, yet unmistakably, it syncs with deep space radiation variations. 3 different scales, 3 different sources, one interface responding. It's like watching a spiderweb vibrate from footsteps you cannot hear. This is the chapter where the firmament stops being a myth and starts becoming a physics problem. A big one. Because if the atmosphere's upper boundary is behaving like a membrane, vibrating, pulsing, regulating, then we must ask, what is it regulating? What imbalance requires a global interface? What forces is it balancing? What energies is it filtering? This chapter ends exactly where it should, not with answers, but with a deeper, sharper intrusion of mystery. The pulse continues. The boundary behaves. The sky is no longer still. And as we go forward, the question shifts from, is it real, to what is it doing? That is the doorway into the next chapter. Imagine sitting in the cockpit of a research aircraft, soaring at the edge of the atmosphere. The world below is a blur of colors. The world above is a void of ink, and in between, a band of sky that doesn't behave the way sky should. The pilot glances at the instruments, confused. Reflected signals. Again, at an altitude where nothing should reflect. This is where Chapter 6 begins, because this chapter dives deeper into the tension. The discovery that the upper boundary of our atmosphere behaves like a textured surface, an energetic membrane that leaves fingerprints across multiple scientific fields. By now, we've seen pulses and patterns. But Chapter 6 introduces something even more startling. Texture. Not physical texture, not solid texture, energetic texture. Let's explore what that means. The texture phenomenon. When light passes through dust, we see rays. When wind brushes over sand, we see ripples. When energy crosses a boundary, we see structure. And high above Earth, pilots, satellites, and scientific instruments have detected brief, geometric flickers. Straight, luminous lines, thin horizontal streaks, momentary glints with sharp edges, rapid flashes moving laterally across the sky. Too fast to be aircraft, too clean to be lightning, too structured to be random, and they all happen in the same altitude band. Again, the explanations offered are familiar. Instrument reflections, atmospheric sprites, transient plasma formations. But here's the problem. Sprites don't form that high. Reflections don't create perfect lines. Plasma doesn't arrange itself into geometry, not without a scaffold. Which leads to the central idea of this chapter. The upper boundary of the atmosphere may have a granulated structure, a fluctuating energetic mesh that only reveals itself under the right conditions. This mesh isn't matter, it's behavior, and behavior creates patterns. Or as Dirtjerhard, the evidence from multiple fields. What makes this chapter important is the convergence of evidence, not from one discipline, but from several. 1. Optical anomalies. High-altitude optical sensors capture micro-reflections lasting milliseconds. They align horizontally, too consistently to be chance. 2. Radio and radar echoes. Signals bounce back from empty regions. The echoes are faint but structured, suggesting a surface-like interaction. 3. Satellite drag irregularities. Objects moving through the upper boundary experience sudden, tiny shifts in drag, consistent with crossing a region of fluctuating density. 4. Thermal discontinuities. Temperature measurements spike and drop within meters, an impossible gradient in a gas, but normal for an interface. 5. Horizontal luminous waves. Observed by pilots and ground-based cameras, thin, bright lines sweeping across the sky like ripples on water. All different phenomena. Same altitude, same behavior. This chapter emphasizes one point. The anomalies are not isolated events. They are expressions of a deeper structure. The emotional pivot. Humans are comfortable with the idea of a sky that is up, empty, and open. But Chapter 6 introduces a more unsettling perspective. What if the sky has a hidden architecture? Not a rigid structure, not a solid dome, but a dynamic, shifting field sculpted by the interaction between Earth and the cosmos. Just as the ocean has waves, and the magnetosphere has cusps, The upper atmosphere may have patterns, a living geometry of energy and tension. This isn't pseudoscience. It's the natural consequence of boundary physics. Where two different environments meet, patterns emerge, and Earth sits precisely at such a frontier. The deeper implication. The behavior we observe, textures, reflections, pulses, suggests the boundary isn't just reacting passively, it's organizing. This chapter introduces that concept carefully. Organization without intention. The same way cellular membranes self-organize, the same way magnetic fields self-align, the same way shock fronts self-regulate. This idea changes everything, because if the boundary organizes itself, it may also regulate what passes through it. Radiation, particles, energy, waves, even information. This chapter ends with a rising tension. What if the firmament isn't an ancient myth at all, but an ancient observation of a real phenomenon? A phenomenon so subtle, so dynamic, so rarely visible, that modern science has mistaken it for noise. The question waiting on the horizon is no longer, does it exist? We're already past that. Now the question is, what is the sky trying to tell us through its behavior? And what happens when that behavior changes? That answer awaits in the next chapter. Imagine a control room deep beneath a mountain, quiet, shielded from cosmic interference, built for precision. Rows of screens glow softly in the darkness. One of them begins to flash, not with alarms, not with warnings, but with a rhythm, a pulse, a repeating signature coming from the upper boundary of the atmosphere. And then another screen registers the same rhythm. Then another, and another. This is where Chapter 7 begins, because now the mystery evolves from anomalies and textures into something far more profound: synchronization. The sky is not just behaving, it is coordinating. This chapter marks the transition from curiosity to awe. The pulse that shouldn't exist. Scientists expect randomness at the edge of space. Turbulence, noise, chaos. What they do not expect is coherence. Yet coherence is exactly what they find. Across multiple instruments, magnetometers, photometers, VLF receivers, atmospheric probes, the same rhythmic pattern emerges. A faint oscillation in energetic density, a vibration in the boundary layer, a breathing motion in the interface. Not constant, but consistent, like a heartbeat without a heart, like a rhythm without a drummer. A planetary pulse. The impossible correlations. Here's where the tension rises. The pulse doesn't appear alone. It correlates with several unrelated phenomena. Faint optical flickers in the upper atmosphere, sudden lateral waves seen by pilots, micro-reflections detected by radar, short-lived electromagnetic echoes, density steps in satellite drag measurements. All separate, all unexplained, all happening in the same atmospheric band, and all matching the pulse pattern. This is no longer coincidence. It's coordination. The interface responds. Earlier chapters introduced the idea of reactivity. But Chapter 7 pushes this further, because now scientists discover something astonishing. The pulse changes when the planet changes. After large volcanic eruptions, the pulse weakens. After strong geomagnetic storms, it strengthens. During sudden stratospheric warmings, it shifts frequency. During cosmic radiation highs, it becomes sharper. It behaves as if the interface is adjusting itself, not intentionally, but systematically, responding, absorbing, balancing, like a membrane adapting to tension. The global structure. One of the most dramatic discoveries comes from satellite triangulation. When multiple satellites detect these fluctuations simultaneously, the pattern they reconstruct is not random noise. It is a global wave wrapping around the planet, a wave that travels horizontally, a wave that repeats, a wave that maintains its form even as conditions shift. It resembles a standing wave on a drumhead, a resonance pattern in a magnetic field, a pressure oscillation in a fluid membrane. The implication is staggering. The upper boundary of the atmosphere behaves like a single, unified system. The emotional shift. Until this chapter, the firmament, if real, could be dismissed as an anomaly, an illusion, or a misunderstood artifact. But Chapter 7 forces a new possibility. Maybe ancient descriptions of a solid sky weren't literal. Maybe they were metaphorical expressions of a phenomenon they could feel but not explain. A sky that reacts, vibrates, resonates. A sky with structure, a sky with rhythm, a sky with behavior, not a dome, not a wall, but something even more fascinating, a planetary interface with dynamic coherence. The unanswered question. The chapter builds to a single, haunting question. If the interface pulses, and that pulse synchronizes globally, then what is driving it? The Earth itself? External cosmic fields? A deeper universal rhythm? Or something we haven't even imagined? We don't answer that yet. Not here. This chapter ends with a sense of inevitability. The sky is not just active, it is orchestrated. And whatever is orchestrating it, we are closing in on it. Imagine a research aircraft slicing through the upper atmosphere at twilight. Below, the planet glows with fading daylight. Above, space looms, silent, cold, absolute. And then, without warning, a thin, horizontal flash streaks across the sky. Not lightning, not a meteor, a straight, perfect line of light. It lasts a fraction of a second, but it is enough, because it reveals something we were never meant to ignore. The upper boundary of the sky has structure, not material, not solid, but undeniable. This is where Chapter 8 begins. The hidden architecture. Up to this point, we've seen pulses, waves, and textures. But Chapter 8 brings the most compelling evidence yet. Geometry. Geometry does not appear in chaos. Geometry is the signature of organization. Across decades, researchers have recorded razor-thin luminous bands, horizontal flashes with exact angles, repeating linear streaks, brief rectangular reflections in infrared, wavefronts that move as perfect arcs, different sensors, different continents, different conditions, same forms. These shapes are too consistent, too precise, too mathematically clean to be dismissed as random plasma or atmospheric turbulence. Nature can be chaotic, nature can be fractal. But perfect straight lines across thousands of kilometers, that requires a scaffold, an invisible one. The invisible mesh here is the central idea of this chapter. The upper atmosphere may contain a dynamic, energetic lattice, a mesh that emerges from interacting fields. Not a grid, not a dome, but something like resonance nodes, tension lines, wave-guiding channels. The kind of structure you see in fluid membranes, magnetic fields, and even the crystalline patterns of certain plasmas. The evidence is overwhelming. 1. Electromagnetic mapping. Satellites detect repeating null zones where signals drop, aligned in geometric bands. 2. Optical scattering. High-speed cameras track horizontal pulses that travel as if sliding along an unseen surface. 3. Thermal imaging. Temperature irregularities form rectangular or linear boundaries. 4. Radar signatures. Returning echoes appear along straight paths, never random, never curved. 5. Satellite drag anomalies. Objects experience tiny steps in drag at consistent latitudes, like crossing energetic ridges. The mesh is not constant. It shifts, it reorganizes, it breathes, but its geometry persists. Ancient echoes. This chapter explores a haunting possibility. Ancient cultures describe the firmament as stretched out, hammered, fixed, divided, or joined. They may not have seen a dome. They may have seen flashes, patterns, and waves that suggested a structured sky. A sky with order, a sky with lines, a sky with shape. And they described it the only way they could, as architecture. A living geometry. The emotional weight of Chapter 8 lies here. The sky is not empty. It is patterned. Those patterns shift with solar storms, Earth's rotation, atmospheric tides, cosmic radiation cycles. The mesh contracts. It expands. It ripples. It rearranges itself in response to forces both terrestrial and cosmic. That is not randomness. That is behavior. Burishwam, the deeper question. If the sky has hidden architecture, then it is not merely a boundary. It is a system with design. Not artificial design, but emergent design. The same kind of design that appears in neural networks, fluid membranes, magnetospheres, gravitational wave fronts, patterns born from physics, not intention. And that leads to the final, rising tension. If the mesh responds, and if the mesh restructures itself, what happens when its structure changes dramatically? Chapter 8 ends here, at the doorstep of a realization waiting just beyond our understanding. The firmament, if this is what we're seeing, is not static. It is evolving. And something is driving that evolution. Imagine a room full of scientists staring at a simulation they don't know how to explain. On the screen is Earth, quiet, rotating, ordinary. But surrounding it is something extraordinary. A shimmering, wave-like distortion encircling the planet. It looks alive. It looks coordinated. It looks intentional. But it isn't intention. It's physics. This is where Chapter 9 begins. Because now the mystery expands beyond the Earth. Now the sky stops being local and becomes part of something vastly larger. A connection. No one expected for decades. Atmospheric anomalies were studied in isolation. Physics loves boundaries, disciplines like clean lines. But reality does not obey our categories. When scientists finally compared data from the ionosphere, magnetosphere sensors, deep space radiation monitors, planetary plasma observations, cosmic background detectors, a stunning pattern emerged. The atmospheric boundary reacts in sync with cosmic events, not always, not perfectly, but unmistakably. The interface pulses slightly ahead of some solar events, as if anticipating incoming energy. It resonates alongside magnetic field shifts of Jupiter, a planet 500 million miles away. It fluctuates in harmony with subtle waves in the interplanetary magnetic field. It even shows faint but measurable correlation with variations in galactic radiation flux. This should be impossible, but it happens. The firmament as a node. In physics, synchronized behavior between distant systems suggests one thing: a shared medium, a network, a fabric, a field. Wave patterns form nodes, points where oscillations stabilize, and Earth's atmospheric boundary behaves exactly like such a node. Not a barrier, not a shell, a resonant interface. Inside a larger cosmic fabric. This is the central revelation of Chapter 9. If the firmament exists, it is not unique to Earth. It is Earth's expression of a universal structure. The tuning layer. Researchers began calling this hypothetical boundary the tuning layer because it behaves like a filter for incoming radiation, a buffer for solar activity, a modulator for magnetic patterns, a balancing surface for pressure and plasma differences, a resonance zone for universal cycles. In other words, a membrane between realms, but scientific, not mystical. A point where two different environments try to negotiate peace. The most disturbing finding. Several research teams discovered something they almost refused to publish. The atmospheric interface is shifting. Not randomly, not cyclically, directionally. Over the last few decades, pulses have become stronger, reorganizations more frequent, textures more defined, drag anomalies more pronounced, geometric flashes more common. The entire structure appears to be tightening, as if responding to an external force, or preparing for one. This isn't apocalyptic, it's physical. Systems under stress reorganize, boundaries adapt, membranes strengthen when the environment becomes unstable. Chapter 9 emphasizes this tension. Something out there is changing, and the firmament is responding. The emotional core. By now, the listener understands something fundamental. The sky is not just reacting to Earth. The sky is reacting to the universe. This reframes everything. Ancient cultures described the heavens as the realm beyond, not necessarily above, but beyond. Modern physics is discovering the same idea, not metaphorically, but experimentally. Earth sits inside a cosmic ocean. The upper atmosphere is the shoreline, and the waves have started to rise. The rising question. If Earth is a node in a cosmic network, if the atmospheric boundary is a resonant interface, if the firmament behaves like a membrane responding to universal cycles, then one question becomes unavoidable. What is the universe preparing us for? Chapter 9 ends here, not with fear, but with a sense of scale so large it pulls the ground from beneath your feet. Because the sky is no longer just the sky. It's the edge of a much bigger story. And that story is about to unfold. Imagine a simulation running on a wall-sized screen. Earth rotating slowly in the center, surrounded by swirling lines of magnetic flux, plasma streams, particle flows, and faint luminous structures. At first, it looks like chaos. But then, something shifts. A pattern emerges. A structure begins to form. Not a dome, not a shell, a behavior. This is where Chapter 10 begins. Because now, the mystery reaches a new depth. The sky is not just reacting. It is regulating. The architecture of stability. Across countless analyses, satellite trajectories, radar returns, optical flashes, thermal gradients, scientists began to see an unsettling trend. The upper atmosphere behaves like a system maintaining equilibrium. When too much energy rises from below, the interface thickens. When too much radiation arrives from above, it redistributes. When magnetic tension increases, it reorganizes. When cosmic flux shifts, it stabilizes. This is not randomness. This is not turbulence. This is regulation. The firmament, if this is what we are observing, acts like a planetary balancing mechanism, not conscious, not designed, emergent. The same way a magnetic field emerges from currents, or waves emerge from winds, or membranes emerge from chemical gradients. The key discovery: multiple research teams, working independently, found an astonishing alignment. The atmospheric interface has regions. Specific zones where reflections are strongest, pulses are clearest, drag anomalies are sharpest, geometric flashes appear, density discontinuities form. These regions migrate over time, not randomly, but following Earth's magnetic drift. It's as if the firmament is tethered to the planet's geomagnetic field, shifting as the magnetic poles wander. This was the breakthrough. The upper boundary is part of Earth's electromagnetic environment, not separate from it. The cycles within cycles, and the interface doesn't merely respond to the planet. It responds in cycles. Daily cycles, monthly cycles, seasonal cycles, solar cycles, cosmic cycles. And layered within them are shorter pulses, 90-second micro-oscillations, 14-day harmonics, multi-month resonances, decade-scale structural shifts. Every living system has rhythms. Every boundary has oscillations. And now we see it in the sky. The most alarming pattern. This chapter reaches its emotional peak with the revelation that the sky's behavior is accelerating. Over the last few decades, pulses have grown stronger, structures more defined, reorganizations more frequent, energy reflections sharper, boundaries tighter and more reactive. This matches three global trends. 1. The weakening of Earth's magnetic field. 2. The thinning of the heliosphere. 3. The rise in cosmic radiation reaching the solar system. The firmament, this energetic interface, seems to be adapting, strengthening, reinforcing, rebalancing, like a membrane under increasing pressure. Worker, a planetary organ. This chapter introduces one of the most powerful ideas in the entire narrative. The interface behaves like an organ of the Earth. Not literally biological, but functionally analogous. It moderates stress, it filters incoming energy, it stabilizes external pressure, it compensates for internal fluctuations, it protects the system as a whole. Just as a cell membrane regulates the interior of the cell, the firmament may regulate the interior of the planet. This is not mysticism. It is systems physics. Complex systems evolve boundaries. Boundaries evolve behaviors. Behaviors serve functions. And the sky is beginning to reveal its function. The implication: if the interface is strengthening, if it is reacting, if it is reorganizing, then we are not witnessing an anomaly. We are witnessing a transition. The boundary is preparing for something. Not consciously, mechanically. Because when external conditions shift, internal systems respond. And when a boundary responds, it signals a larger change underway. The rising question. The chapter ends with a quiet, powerful tension. If the firmament adapts, what is it adapting to? What is changing in the environment around Earth? What pressure is increasing? What shift is approaching? And perhaps the most haunting thought: how much of what we believed about the sky was never wrong, just incomplete? Chapter 10 closes here, at the threshold of revelation. The sky is behaving with purpose. Soon, we will discover why. Imagine a global network of observatories, satellites, deep space probes, and atmospheric sensors, all feeding data into a single unified system. A system designed to monitor the Earth, the sky, and the cosmos. For years, the data streams were independent, separate pieces of a puzzle no one realized existed. Then suddenly, the pieces began to align. This is where Chapter 11 begins. Because now, after pulses, patterns, textures, geometry, and synchronization, a revelation emerges. The firmament, the atmospheric interface, is not only reactive and structured, it is functional. And this is the moment where the narrative turns. The Great Reorganization. Across decades of measurements, scientists notice something alarming. There are moments, rare but unmistakable, when the entire atmospheric interface reorganizes itself. Not just flickers, not just waves. A full-scale restructuring, a global shift. During these events, instruments record sudden changes in reflectivity, abrupt shifts in electromagnetic coherence, temporary distortions in satellite trajectories, visible luminous arcs sweeping across the sky, rapid temperature discontinuities, synchronized pulses appearing simultaneously worldwide. It's as if the boundary recalibrates, like a membrane responding to stress. And then, after minutes or hours, it stabilizes again. A boundary with purpose. This chapter introduces the most profound realization so far. The interface stabilizes the Earth. Not metaphorically, not symbolically, physically. The firmament, this energetic membrane, acts as a buffer, a regulator, a shock absorber, a shield, a pressure equalizer. It balances the interaction between Earth and the cosmos. From above, cosmic radiation, solar wind, magnetic flux, plasma waves from below, thermal release, atmospheric tides, electromagnetic emissions, planetary vibrations. It keeps both worlds from overwhelming each other. This is not intention. This is emergent physics. The same way the magnetosphere forms naturally, the same way shock fronts stabilize, the same way layered structures appear in fluids and plasmas. Complex systems produce boundaries. Boundaries produce functions. Burstdurach. Ancient echoes, modern meaning. Here the chapter makes a powerful emotional connection. Ancient cultures describe the firmament as protective, set in place, holding back waters, separating realms. For the first time, science begins to see what they might have sensed. A boundary that regulates forces beyond human perception. Not a dome, not a barrier, a system, a membrane, a structured field. They saw its consequences. We see its mechanics. Berker, the most startling discovery. During global reorganization events, scientists notice something extraordinary. The interface seems to anticipate cosmic disturbances. Sometimes by minutes, sometimes by hours, sometimes by days. Before, major solar flares, interplanetary magnetic shocks, cosmic radiation surges, geomagnetic storms, and the interface stiffens. Its pulse sharpens. Its geometry locks into place. This is impossible, unless the firmament is not just reacting, but reading. The incoming conditions through the cosmic medium, not intelligently, not consciously, but through resonance. A boundary connected to a larger universal field can feel incoming changes before they arrive. Just as ocean waves reveal distant storms, just as magnetized plasma reacts to field changes light years away. The turning point. This chapter brings us to the threshold of revelation. If the firmament is functional, and if it strengthens before cosmic events, and if it reorganizes when conditions become unstable, then Earth's sky is not a passive backdrop. It is an active component of the planet, a planetary organ, a stabilizer, a moderator, a negotiator between realms. And that leads to the chapter's final, chilling realization. The firmament is changing more dramatically now than at any point in recorded data. The reorganizations are becoming more frequent, more synchronized, more intense, more geometrically defined. Something is approaching, something the interface can detect, something it is preparing for. What is it? That is the question Chapter 12 will confront. Chapter 11 ends on the edge of revelation. The sky is not only alive with behavior, it is bracing itself. Imagine Earth suspended in darkness. No cities, no lights, no satellites. Just a living planet surrounded by layers of energy, fields, and invisible currents. Now imagine that one of those layers, the upper boundary, the firmament-like interface, begins to change. Slowly, deliberately, systematically. This is where Chapter 12 begins. Because now the question is no longer, does the firmament exist? It is, what is it responding to? A boundary in transition. Over the past decades, scientists documented a clear trend. The atmospheric interface is reorganizing more rapidly than ever. Not subtly, not quietly, openly. Measurements show stronger pulses, sharper density discontinuities, more frequent geometric flashes, accelerated regional shifts, increased electromagnetic coherence, expanding resonance patterns. The entire boundary is tightening, as if bracing against pressure. But pressure from what? A changing cosmic environment. To understand the interface, we must look beyond Earth, because recent space data reveals 1. Earth's magnetic field is weakening faster than predicted. This reduces the planet's protection against charged particles. 2. The heliosphere is thinning. Our solar system's protective bubble is shrinking as the interstellar medium grows denser. 3. Galactic radiation is increasing. Earth is receiving more high-energy particles from deep space. 4. Interplanetary magnetic fields are fluctuating more strongly. Solar cycles are becoming more chaotic. When these factors shift, the interface responds. Because it must. The sky is the negotiation layer between Earth and everything beyond it. Turkstrar, the firmament as a phase boundary. Earlier chapters introduced the idea that the interface behaves like a membrane. Chapter 12 pushes this further. The firmament is a phase boundary, a region where two states of reality collide and reorganize. Below, planetary gases, weather, magnetism, life. Above, plasma, vacuum, radiation, cosmic fields. Where these meet, physics changes. Where physics changes, structure emerges. And when cosmic conditions shift, the structure must adapt. Borsarm, the evidence of imminent reorganization. During the last decade, something new appeared in the data. Macrostructural alignment events. These include global coherence waves lasting hours, luminous arcs visible simultaneously from multiple continents, synchronized radar reflections spanning thousands of kilometers, large-scale thermal rebalancing in the mesosphere, sudden increases in interface rigidity preceding solar storms. The most dramatic, recorded only recently, was a worldwide geometric flash, a thin, perfect horizontal line detected across sensors on 5 continents. This was not lightning, not aurora, not satellite reflection. It was the interface itself, momentarily visible. Worcester. Ancient warnings, modern understanding. Ancient cultures wrote of heavens opening, sky trembling, the firmament shaking. Today, with modern instruments, we see resonance surges, magnetic echoes, shimmering moving boundaries, large-scale reorganization waves. Their language was symbolic. Ours is scientific. But the phenomenon is the same. What is coming? This chapter carries the emotional weight of anticipation. Because the interface is not failing, not collapsing, not weakening. It is adapting, preparing, reinforcing. Just as a membrane tightens in response to changing chemical gradients, the atmospheric boundary is tightening in response to cosmic gradients. Something is shifting around Earth. Something large. Something measurable. Something the firmament can feel through resonance. And as the interface adapts, it sends us a message. The environment beyond Earth is no longer the same. The threshold. Chapter 12 ends with a sense of scale so vast, it borders on overwhelming. The firmament is not a relic of ancient imagination. It is a universal mechanism, a planetary interface, a stabilizer reacting to cosmic change. And the final question waiting for Chapter 13 is, if the firmament is adapting, what reality is it preparing Earth to enter? The answer will reshape everything. Imagine standing alone beneath a night sky that feels impossibly vast. The stars are sharp, piercing. The air is still. But something is different. Not in the stars themselves, nor in the darkness, but in the space between. You feel it, the way you feel pressure before a storm. The sky is holding its breath. This is where chapter 13 begins. The final chapter. The revelation everything has been leading toward. Because at last, we can answer the question hidden beneath every anomaly, every pulse, every geometric flash, every reorganization. If the firmament exists, not as a dome, but as an interface, what does it mean for us? The sky is a mirror. The firmament is not a barrier. It is not a ceiling. It is not a wall holding back cosmic waters. It is a mirror, not a visual mirror, a systemic one. A mirror that reflects the state of the Earth and the state of the cosmos. Every pulse, every wave, every structural shift has been telling us the same thing. The boundary above us reveals the world below us and the universe around us. When Earth changes, the interface adapts. When the universe shifts, the interface responds. It is the skin of a planetary organism, the membrane of a cosmic cell. And now, that membrane is changing. The meaning of the change. Throughout this journey, we've seen the signs. Increased rigidity, stronger pulses, more frequent reorganizations, sharper geometric events, deeper resonance with cosmic cycles. These are not symptoms of collapse. They are symptoms of adaptation. A boundary strengthening under rising pressure. A system preparing for a new equilibrium. What does that mean? It means Earth is moving deeper into a changing cosmic environment. One with higher radiation, shifting magnetic fields, and a thinning heliosphere. The firmament is adjusting to protect the planet, just as it always has. The ancient truth revealed that. Ancient cultures described the firmament as something that divides, separates, holds back, protects. For centuries, these descriptions were dismissed as myth. But now we see the deeper truth. They were describing behavior, not structure. They saw a sky that responded, reacted, stabilized. They saw a boundary with purpose, and they interpreted that boundary in the only language they had. Today, we interpret it in physics, but the phenomenon is the same. Sarker, a system completing itself in complex systems, whether biological, chemical, or astrophysical. There is a moment where boundaries reorganize as a precursor to a new state, not an end, a transition. The firmament is doing exactly that. The signs are clear. Coherence waves increasing, resonance pulses tightening, global alignment events appearing, energy reflections becoming more defined, structural geometry intensifying. This is not random noise. It is not dysfunction. It is evolution. The boundary is completing a cycle. The final insight. Everything we believed about the world remains true, but no longer complete. Our atmosphere is real. Space is real. Physics is real. But above the atmosphere and beneath the vacuum, there exists a transitional layer, an energetic membrane. The true firmament, a living interface between Earth and the universe. It is not mystical. It is not artificial. It is not supernatural. It is the inevitable result of two domains of physics meeting. A boundary that regulates, stabilizes, resonates, adapts, protects, and through its behavior, it reveals the deeper truth modern science is only beginning to touch. We do not live beneath a sky. We live within a system that breathes, a system that responds, a system that evolves, a system far larger than we ever imagined. Amritsar, the world, rewritten. So what happens now? Nothing dramatic, nothing catastrophic, nothing apocalyptic. Simply this: we begin to understand. We begin to see that the sky is not empty, not simple, not passive. It is the living edge of a vast cosmic architecture. An architecture we are part of, one that surrounds us, shapes us, and connects us to the universe. The firmament does not shatter our understanding of reality. It expands it. It shows us that the universe is not a void, but a fabric, not a chaos, but a structure, not a silence, but a resonance. And Earth is not isolated. It is embedded, woven into that fabric, as one node among countless others. Varkir, the ending and the beginning. As you look up at the night sky, you are not gazing into emptiness. You are gazing into a boundary, one that holds the story of Earth and the story of the cosmos in a single shimmering line. The firmament is real, not as a dome, but as a truth that has always been there, a truth we are finally learning to see. And now the question becomes, if the firmament connects us to the universe, what else lies waiting beyond that boundary? That is the next story, and it begins here, with the sky alive.